Hey everybody, what's up? Lars here. It is time for the second review video for Unit 3. And in this video, we are going to go over file I/O. When I say I/O, I mean input and output. And when I usually do this video, I tell the story of the dinosaur days when I went to school for computer science and how back in the 80s we hadn't really wrapped our head around how to properly teach computer science yet. It was still young. Most computer science departments came out of math departments in the 60s and 70s. So when I'm going to school in the mid-80s, things are still kind of young and they're still wrapping their heads around how to teach computer science. We still had an intro course where you got taught the basics, a lot of the things that you're going through now. And then we had a data structures course, teaches you how to organize your data and do some, time-tested things with it. But then after that, it was kind of the wild, wild west. There was an operating system course and this and that and a whole bunch of different things. What they did do was they threw a bazillion different computer languages at you. So if you were to look at my college transcript, you would see a COBOL class, an RPG class, a Fortran class, a Pascal class, PL1, which was C before it was C. And you got all of these different languages. And what they tried to do was spread around different concepts. But when you learned a whole bunch of different programming languages, you realized they were kind of all the same because they were kind of doing the same things. There was data, and then there was iteration, and then there was functions, and then there was different ways to do things. One omission that I always noted, even as a 20-year-old, was that most of these classes did not go over file I/O. And I thought it was very odd because any professional programming job, anything you do in the real world, no one's ever going to say to you, produce the first 200 Fibonacci numbers or, create a list with 200 natural numbers and go through them and find out if they're multiples of 12. That never happens in the real world. In the real world, someone's going to give you a file. And like programs, which are basically saved, codified pieces of logic that we run, files are basically that for your data. They're a store for your data. So your program is the logic and the things you do with your data, which is also stored. You'll notice that so far we've been dealing with data that's been hard-coded in our programs or interactive as we fill things in while our programs run. So we haven't really been dealing with reading data from a file, and that's what people do. You get an Excel spreadsheet or you get a comma-separated value thing, and that's what we're going to deal with today. And you do things like that. So in the real world, you're always going to get a file, and I always thought it was a surprise when, even as a kid, we never did file I/O. You were kind of expected to go off and learn it on your own. So even back then, I told myself that if I ever became a computer science instructor, I was going to do file I/O. Every time I run this course, I do it because I think it's important and I want you to see it, and I think it makes sense in this particular unit because it's kind of like modularity. We're separating out and taking care of our data and putting it in a different place. So without further ado, let's do some stuff with files. I have a whole bunch of stuff already set up for us. Let's see. I set up the Python on there. I set up a program right here. And I have some files that we're going to take a look at later. First thing we're going to do right here is the simplest thing we can do. And if you think about the middle third of your slides, what are the three main operations we do when we deal with files? We open them, then we read from them, and then we close them. So right here you can see I just created a little string variable called infile, and then I made it equal to the string small e22.txt, and you can see that that's the name of that file right there. And when you look at it, you can see it's a bunch of names in double quotes separated by commas. I forget how many there are, 200 and something, I forget. I used to do this with 500, now it's 200 or something. We'll take a look at it later. But you can see, I'm looking at it in Notepad and Windows, but you can see all of those names there. And we're going to look at that in a second. I think it's called E22 because it's the data file for Project Euler, number 22. And when I reduced it, I just called it small. So that's where the name comes from. It's small 22. So this program, filestuff.py, is in this directory. So if I just give it this as a file name, it'll look in the same directory as the program, and we have it there. So things are going to work, okay? We could also do a absolute path if we had to do it, but we don't have to do that. We're just going to keep all of our data files in the same directory as our program, so we can just give the file name, okay? Then what I do is I create a variable called f, and I assign it the result of the open function, which opens a file, and then the name of the file, which in this case I just give a string because I've already assigned it the value small e22.txt. And then here in single quotes or double quotes, because it's a single character string, is the character R. And the reason we give it an R is because we're telling it to open the file for reading. All right? We have to tell it the purpose, because we could also write the things and we could also do some other things. And you're going to learn later that what we're doing right now is character-based sequential file stuff. So you're going to start at the beginning of the file and read character by character. That's the way we do things in the beginning when we first get started. Later, you'll learn you can open things as binary objects and you can move around and do random access and blah, blah, blah. Other things like that. But right now, we're doing very simple sequential character-based file reading. So I'm going to say F, open, in file R. And what it's going to do is F here is actually going to be a memory location that's going to point to the front of my file. So then what am I going to do? I'm going to create another variable called data. And data is going to be a string. Data is going to be a rather large string because we're going to do f dot. So we're running a little mini program on f. Remember, we called them methods. We're going to learn about them later. But right now, that variable I created up here, f, I'm running a little mini program on it. I call it dot read. No parameters. Open paren, close paren. And what that's going to do is take the contents of small e22.txt and put it all in one string. So we'll take a look at the length of it. It's going to be one big long string, okay? And then when we're done reading from our file, we're going to close it. So I'm just going to say f.close, open paren, close paren, okay? So right there, boom, 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 in those really quick 4 lines, we could have done it in 3 if I hard-coded the name of the file. We opened the file, read from it, and closed it, all like that. Open, read, close, boom. And then to show you, I'm just going to print the data. So if I run the thing, you can see there it is. All the names have been printed. All right, let's see how many of them there are. Let's do a len real quick. 2083. Okay, but is that how many names there are? That's how many characters there are. Because right now, I've got a string, and if I do the length of a string, it just tells me how long it is. So there's 2,083 characters. We're going to change that. As a matter of fact, we're going to change that right now. Because what we have is a string with all of those characters in it, but we want to have a list of names that we can look through and try to find individual names. So how do we do that? We do that by going through a process called cleaning your data and getting it into a form that you want. And I already have code to do that. Uh-oh. Get out of here. Not ready for you yet. All right. So I'm just going to comment that out and leave it there because I'm going to take this code and I'm going to give it to you at the end of the thing. I'll put it up in Sakai. All right. I want to do 2 things here. What do I want to do? Over here, I have a comma separated value situation in my string. So I know I have little mini programs or methods I can run on my data. Right now my data is a string, so what do I want to do? I'm going to take all of those quotes and I'm going to get rid of them. So I'm going to do a replace. I'm going to replace double quotes with nothing. That's 2 single apostrophes right in a row. Bang, bang. Okay? So that's going to replace that with nothing. So let's do that first. I'm going to Zotz out that second one. So if we go through that process and I print, look at that. See? All of my double quotes are now gone. So now I have name. As you can see, that spreads out because there's no end lines in there. All right, so now I have name, comma, name, comma, name, comma, name, comma. And that's exactly what I want because the second thing I'm going to do is I'm going to say data, assign, data dot split. Split is a very interesting, and you read about it in your slides, it's a very interesting and insanely useful method that you run on strings. Because what do? You give it a delimiter or something that is separating things, in our case a comma. And this is how you do comma separated value stuff. And what split does is it splits a string by whatever you give it as a delimiter and places it in a list. So data after this operation is going to be a list. You're going to split that string everywhere there's a comma. You won't include the comma. And you're going to put it in a list called data. Watch it work. So now I have all of these names, but as you can see, there's my start bracket, and there's my end bracket, and now I have everything in a list. Now, if I do a len, what's going to happen? It's going to tell me 235. That's how many names are in there, because now I have a list of names of objects. Okay? So, you might be saying, well, big deal. So what? You took a big string full of names, and now you got a list full of names. But it's incredibly important. As you can see, the list put everything in string form. So I got quote, then I got quote at the end. All right? Didn't put the double quotes back, but I've got quotes because all these things are strings. Think about it. I can use this data now. I can examine those names because I have them in a list. And what can I do with a list? I can iterate over it. Look at this. I got some code already made for us. There's more down there. Okay? So what am I going to do? With my newfound list, I'm going to set up a counter. I'm going to say for I in data, that's my list. I don't need range. What do I care about range for? I have a list. I'm going to iterate over it. All right. This may be the first time you're seeing this. C plus equals 1 is the same as C equals C plus 1. It's a little shorthand operation. It's actually an operator, but it's a shorthand operator for a counter. Okay? It's the same as C assigned C plus 1. Okay? You can do the same thing with the minus if you want to decrement. And then I just do a simple if. I looked for the name Anna because I think Anna's in there. Can I find it? Is it there? I don't see it. I think it's there, though. And then what I'm going to do is if I find Anna, I'm going to print I, and I'm going to print C. Okay, so I will print Anna, and then I'll print what space Anna is in. And then at the end, I print C to check my counter, and then I print the length to make sure my counter is working properly. Let's give it a go. Go, go, go. So we found Anna. Anna is in the 181st spot. And look, oh my, that never happens. I usually can't find it, and I make jokes about how blind I am, but look, I found it. Ha, ha, ha. Squirrel finds an acorn every once in a while, people. So Anna is right there, and I know from down here that it is the 181st spot, okay? And my counter's working properly because it's the same as the length of my list. So I know my counter's in good shape. All right, just because I found Anna and printed it, I didn't do a break. So I went right ahead and I finished going through that entire list. So my counter is good. I do 235 right there, okay? So that was pretty good. Yes, very rudimentary, but this is the beginning of data science right here. I took a file full of names, I read it in, I cleaned it up so it was usable, and then I came down here and I searched through the list, right? I mean, that's what we're all about. We're all about data, and this is data analysis. As simple and rudimentary as it is, it's analysis. I went searching for something, and I found it. Okay? And I know what spot Anna is in the list now because of this particular code, all right? I'm going to put this up on the web, so don't worry. You don't have to code, and you don't have to do that. But I want you to get the gist of this. Reading files is how we're going to do things. So you read the file in, you get it into a form that you can use the data, and then you go ahead and you perform some kind of task like we just did right here, searching through Anna. All right? All right. There's two more things that we have to go through. Let me zot this out. 1, 2, 3. 1, 2, 3. And then this. Oop. Do I need this? No. All right. These three little lines right here. This is called a with as construct. And I want to show it to you because most Python programmers use it. Nobody does open and this and that and blah, blah, blah. When you have a file, you do a with as. You do with, open, and then the name of the file, and then to read, and you say as f to get the variable, and then you say for line in f. Well, actually, f is the name of the file. And then you say for line is just a variable name. That could be dog, that could be a, that could be I, but I always call it line because it makes sense. And then you say for line in f, print, and then we'll print the whole file. Okay? What are we missing right there? Can you see? There's two things we don't have. We went over the process. We said open, we said read, and then we said close. Look at those 3 lines. There's no read, all right? We do it automatically in the 4 as we iterate through the file. We do it line by line, line by line, line by line. Okay, that's the way a with as works as far as an open is concerned. And then the close happens automatically. At the end of the loop, when you come out of the loop, the with as construct will close what we used to call the file handle, or the thing that points to the file. So it automatically gets closed for you. So it's a nice, easy little thing. If you have a file and you know you're reading it line by line, like the different things we've been doing, then why wouldn't I use it? And then line by line, do what I want to do. In this case, I'm going to open up a file called numbers2.dat. And I'm going to show it to you first. It's right here in my little directory. And I'm going to look at it, and it's just 12, 23, 34, 45, on down the line. Okay? That's all it is. It's numbers2.dat. I'll be giving you this too. So when I run this, it's just going to print it out as an integer. And you're going to see why I print it out as an integer later. So there you can see, look. Now this is becoming nice and confusing, because I got to move things along. But look at that. That's all it is. Just took my file and printed it out to the screen. All right? So that's all that did right there. That's another way to open files, as long as you know you're going line by line. All right? And then you can just iterate through the file, and that's what that does. Super simple, super helpful, but don't let it confuse you. You've still got to open, you still got to read, and you've still got to close. All right? All right. Now, just when you thought you had everything figured out, you've got to realize that reading isn't the only thing we do with files. We also write to files because we want to keep our data someplace when we discover it. So what do? I do an open command, but now I give it a W. And you'll see I'm creating a file called outnums.dat. Look here. No such thing. Okay? There's nothing in my hands. There's nothing up my sleeves. There is no outnum in that directory right now. All right? So I'm going to create it. And I'm going to create a variable called OF. I'm going to assign it the result of open. And the file name is outnums.dat. And I'm going to open that for writing. Then I'm going to grab my numbers. Got to make it numbers too. I'm going to grab my numbers file. And I'm going to open it as F again. And then I'm going to say for line in F. And then I'm going to do a code block. What am I going to do? I'm going to print it, just like I did over here. I'm going to print it, but I'm going to make it an integer when I do. Then I'm going to create a variable called bump. And bump is going to be assigned the integer value of the line, 12, 23, 34, plus 1. Now, because I made it an integer, I can use arithmetic. So bump is going to be 13. All right? And then I'm going to run, instead of read, and I'm using my output file when I do it, I'm going to say OF for output file. Wasn't that clever? Dot write. And what do I write? I got to remember I have a sequential file here, so I want to write characters. So I make bump an integer again. I go back. I read a string, but I turned it into an integer to do some arithmetic, and then I got to turn it back into a string. And then, because I'm a schmarty, I'm going to also concatenate an end of line. So when we create our output file, it'll have the same format as numbers2.dat. Okay? And then when this line is over, it just goes to the top of the line again. Grabs 23, prints it, creates a variable called bump. Integer of line is 23 plus 1 is 24. OF write the string of 24 and a new line. So the output file will have 24. Okay? Everything should work. Everything should be fine. Yes? Yes? Let's find out. Things to look at that. Obviously, this part, the print int line worked great. Okay? And let's go here. And we have outnums. Outnums is there. But wait. When we look at it, we don't have anything. Nothing there. Why is there nothing there? Should I delete that? I don't have to. It'll write over it. Because of a little way that computers in Python work. When you do OF write, you are not writing to the hard drive. You're writing to a little section of memory called the buffer. The buffer does not write to the hard drive until you close the output file. So you always have to remember the with construct is going to automatically close numbers 2 for you. But you did the open yourself up here. You have to close that file. Because until you close that file, all of that information is just sitting in what's called a little file buffer. It's a little temporary place where you're going to put your output. When you do the close is when it writes. Okay? So now, if I rerun, I get 12, 23, up down the line. Then I come here, I have outnums again, only this time it's got a little something, something in it. And as you can see, I'm in Fat City because look what I got. Every value is one more than its value in num2.dat. You see that? 67 became 68, 45 became 46. Because it's exactly what we do. We add 1 to it. Okay? Always remember, you have to close your output files or you're not going to save the work that's put in there. All right, I realized after I filmed and canned the last video that I promised you a grand finale and I didn't do it. I went and I cleared out all the comments and then I never ran the thing. So I am not going to make the same mistake twice. I am going to get you a finale, but it's not that big a deal here. Let's see. Oh, there's Anna and all her stuff, and then there's the different lists. And did we print out nums again? Yes, we did. Look at that. All right. All right. So that's the basics of file I/O. Okay. You're going to see this because you're going to wait on. This is Thursday night. I'm going to get you this video. Hopefully over the weekend I'm going to be at HackRU, but maybe even from HackRU I'll do the last video. And when I do the last video, I'm going to release the assignments. And you're going to see with the assignments, you're going to be using and manipulating information in a file. And remember this when you're thinking about that, because you're going to have some similar situations and you're going to want to do some similar things along those lines. Okay? All right. Then I'm not going to do any announcements. I'm going to save them for a day or two. At the end of the last video, I already gave you a warning about the project, which is due November 6th. I also told you think about groups. As far as planning for this unit, I'm going to get you hopefully all of the resources by the weekend. The assignments by the beginning of next week, latest. And you're going to have a whole lot of time because this unit doesn't end until October 26th, I believe. Now, that I think is 2 weeks from tonight. So it's not forever. Don't procrastinate that long. Get on things and get going. Because I'm giving you guys a lot of videos. I gave you the FizzBuzz video. I'll be giving you the rainfall video tonight with this one. So you're going to get 2 videos tonight. Then I want to do the video for the quiz. Then I'm going to do another video for Project Euler. Okay? So there's videos coming. All right? And that should be good enough. I'll do some announcements over the weekend, maybe even a long email, just to let everybody know where they are. Hans, Kasim, they're grading assignments, they're grading quizzes, they're filling up the grade book. Hopefully by the beginning of next week, I'm sending out Unit 2 grades to you guys so we can get Unit 2 put to bed, and you can just worry about Unit 3 and your midterm. All right? All right, then I'm going to get out of here. You be good, and I will talk to you in a couple days. If not tomorrow night, then Saturday night from HackRU. All right? All right, I'll see you soon. Bye.